The sky looks normal. Blue, calm, familiar, but somewhere beyond the edge of Pluto something has arrived. No explosion, no warning, no sound, just a silent distortion bending space itself. A black hole, drifting toward us. And for the first time in human history, the solar system is no longer alone. What if a black hole entered our solar system? Not a supermassive monster like the ones at the center of galaxies. Not a cinematic, planet-devouring vortex swallowing everything instantly. But something more subtle, more realistic. A rogue black hole, perhaps a few times the mass of our sun, wandering through interstellar space until it crosses into our cosmic neighborhood. No light, no reflection, no visible warning, only gravity, unseen, unstoppable, and inevitable. To understand what happens next, we must first understand what a black hole really is. A black hole is not a hole. It is a region of space where gravity has collapsed matter into an infinitely dense point, what physicists call a singularity. Around it lies the event horizon, the boundary beyond which nothing can escape, not even light. If our sun were replaced by a black hole of equal mass, something surprising would happen. Earth would not be sucked in. It would continue orbiting just as it does now, because gravity depends on mass, not size. But this scenario is different. This black hole is not replacing the sun. It is entering the solar system, and that changes everything. At first, we wouldn't see it. There would be no glowing sphere in the sky, no ominous shadow. But astronomers would notice something strange. Stars shifting, light bending, a subtle distortion in the fabric of space, what scientists call gravitational lensing. Distant starlight would curve around an invisible point, like ripples around something unseen. That would be our first clue. Then the orbits would begin to change. The black hole enters the outer solar system, far beyond Neptune. Here, icy objects drift slowly in the Kuiper belt. Comets. Dwarf planets, frozen debris from the birth of our system. The black hole passes through this region like a ghost, but its gravity leaves scars, orbits stretch. Paths distort. Some objects are flung outward, ejected into deep space. Others are pulled inward toward the inner planets. A storm of comets begins, not instantly, but gradually. A delayed consequence that will unfold over years. As the black hole moves closer, the balance of the solar system begins to break. Planets do not orbit the sun in isolation. They are locked in a delicate gravitational dance, a balance maintained for billions of years. Now, a new dancer has entered, and it does not follow the rhythm. Jupiter feels it first. The largest planet, holding enormous gravitational influence, begins to wobble. Its orbit shifts, slightly at first. Then more, Jupiter's moons destabilize, some collide, some escape. Some are captured by the black hole itself. And as Jupiter moves, everything else begins to follow. Gravity is not local, it ripples. When one planet shifts, others respond. Mars drifts, Venus trembles, Earth begins to feel it. Days grow longer or shorter. Seasons shift unpredictably. The moon's orbit destabilizes. Tides become violent. Earth's climate begins to collapse, not because of the black hole directly, but because the delicate balance of orbital mechanics is breaking down. This is not destruction, not yet. This is destabilization, the beginning of the end. In movies, black holes devour everything instantly. Planets stretch into glowing streams and vanish. Reality is slower, more precise, more terrifying. Because it gives time to observe, time to understand. Time to realize there is nothing we can do. The black hole doesn't chase Earth. It doesn't target us. It simply moves. And its gravity reshapes everything in its path. Now the black hole approaches the inner solar system. This is where things become catastrophic. Asteroids begin to rain down. Comets, disturbed years earlier, now arrive in waves. Impact events increase dramatically. The sky becomes a battlefield. Fire streaks across the atmosphere. Some impacts are small, others extinction level. Meanwhile, Earth's orbit becomes unstable. It may move closer to the sun or farther away. A slight shift can mean everything. Closer and oceans begin to evaporate. Farther and the planet freezes. Civilization collapses, not in a single moment, but in stages. Infrastructure fails. Food systems break. Global communication fractures. Humanity is no longer preparing for the future. It is reacting to survival. If the black hole passes close enough, a new force takes over. Tidal gravity. This is not the gentle pull that causes ocean tides. This is extreme. The side of Earth closer to the black hole feels stronger gravity than the far side. The planet stretches. Literally, the crust fractures, earthquakes on a scale never seen. Volcanoes erupt across the globe. The oceans surge unpredictably. If the black hole gets too close, Earth itself could be torn apart. pulled into a stream of matter, a process scientists call spaghettification. But even if it doesn't reach that point, the damage is irreversible. Now the ultimate question, what happens to the sun? If the black hole passes near it, their gravitational interaction becomes dominant. The sun may shift. Its position, once stable, begins to move. The entire solar system reorients, or worse. If the black hole captures the sun gravitationally, it could form a binary system, two massive objects orbiting each other. But the existing planetary system would not survive this transition intact. Orbits would be destroyed, planets ejected, others consumed. The solar system as we know it would cease to exist, not in seconds, not even in days. This would unfold over years, perhaps decades. At first subtle anomalies, then growing instability, then cascading consequences. This is what makes it so haunting. We would see it coming, we would understand it, and we would be powerless to stop it. Rogue black holes do exist, formed from dead stars, ejected from galaxies, wandering through the darkness of interstellar space. But space is vast, incredibly vast. The probability of one entering our solar system is extremely low, not impossible, but unlikely. And yet, the universe has existed for over 13 billion years. Given enough time, even the rarest events can happen. Could we escape? Not easily. Even if we detected the black hole early, our current technology cannot move planets. We cannot alter gravity on a solar scale. At best, humanity could attempt survival strategies, underground shelters, space habitats, interplanetary migration, but even these depend on stability, and stability would be gone. This is not a disaster we could fight, only one we could witness. Eventually, the black hole leaves. It continues its journey through the galaxy, silent, unchanged. But behind it, nothing is the same, planets scattered, orbits broken, debris fields where worlds once existed. If Earth survives, it may no longer orbit the sun. It may drift alone, a frozen, dark world in interstellar space. If it doesn't survive, then all that remains is memory, encoded in signals sent long ago. A black hole entering our solar system would not be a sudden end. It would be a slow unraveling. A reminder that even the most stable systems in the universe are temporary. We often think of space as empty, safe, distant, but it is dynamic, unpredictable, and sometimes dangerous. The solar system has been stable for billions of years, but stability is not permanence. It is only a moment stretched across time, and this raises a deeper question. If a single wandering object could reshape an entire solar system, then what else is out there, drifting silently through the dark, waiting to be discovered? Or to arrive?